Thanks, Yvette. Thank you very much. Welcome to this session. Big shout out to the organizers for making this possible, to the sponsors for making this possible as well. Let's have a quick show of hands. It's really hard for me to see those hands, but I will give it my best. It's not on the slides, but let's have it. 3 questions, real quick. Who of you here are running in, let's say, enterprise computing environment that does not include Windows of some kind? Great, so this talk is not for you. So, from the remaining 99.9%, who of you are running an enterprise-grade computing environment that includes Windows but does not use NTLM to your knowledge for authentication? Right. Let's lower the bar a bit. Who of you are running an enterprise-grade computing environment that does include Windows but does not utilize NTLM in tier 0? Wow. Then you've come to the right place. What are we going to be looking at today? We have a lot of ground to cover. We have 30 minutes to provide solutions to problems that cropped up over 30 years. So we'll do a quick recap of why NTLM is bad for your health if you are from the blue corner. If you are from the red corner, then NTLM, of course, is a gift. What Microsoft is doing to help us out of this mess, what the rest of the world seems to be doing in terms of software and hardware vendors that should be aware of these problems as well. And for those of you who are defenders or admins, what you can possibly do today, what you must do today once you get out of this conference and get back to your office or your home office or whatever, and what you as defenders and or admins should look at doing tomorrow. My name is Evgenij. I come from Berlin. It's all over my social media handles, so I can't move away without breaking my whole social media profile. I'm a Microsoft MVP, but not for security, Cloud and Datacenter Management. I've spoken at conferences before, mostly PowerShell-related stuff. I run 3 Microsoft themed user groups out of Berlin. So if you're into Microsoft technology, give me a shout. So a quick recap how NTLM works for the one person in this room who doesn't know how that works. Basically, it's about a user on a client computer, which ideally would use Windows, because NTLM is a Microsoft proprietary technology, introduced in Windows NT. That's where NT in NTLM stand for, to replace LAN Manager, which was the authentication protocol before, which sucked really great time. NTLM in the first issue sucked also, but we'll get into that. So a user that is logged on to preferably a Windows client, would like to access some resource, let's say file share on a server. And for some reason, they negotiate NTLM to authenticate that user. We should all be using Kerberos for that nowadays, but there are scenarios where NTLM will get negotiated even in modern operating systems. So let's assume they have negotiated NTLM. Or if you are from the red team, you have used some protocol downgrade technique and coerced the server to be using NTLM against you. So the server says, well, user, it's good. Prove who you are. And of course, it does not send the user the string saying prove who you are, but it does send the user a byte array, which we call a nonce in cryptography. The user is happy to oblige, and they will. Let's see if this cursor thing works. Yeah. And it sends the server a package of information saying who the user is, the nonce, this byte array that the server initially sent it, and a cryptographic encryption of this nonce by a private key, or it's a symmetric one, using an MD4 hash of the user's password. So now, if both of these communication partners were in a work group, then the authentication data flow would be over, because for authentication to occur, the server would have to know not the password in clear text, but at least this MD4 hash of that password. So the server would be able to redo the encryption. It knows the nonce, it knows the username, it knows the password hash. So the server would be able to verify if this encrypted data that the user is sending is valid for that particular user. Nothing fancy here, and that's what this protocol was actually designed for. It's a challenge handshake type protocol. But enter central authentication, Active Directory domains, or Windows NT domains even. So the server does not know the user. The server doesn't even know if the user exists, so it will go out to a domain controller who ideally should know that the user exists and also know the password of that user, and sends the domain controller this whole information package. The domain controller should be able to verify if that password is valid by redoing the encryption. Again, now the domain controller does know the nonce, it knows which user is meant for authentication, so it should be able to redo the encryption and compare the result to what has been supplied by the server. And if that checks out, then the server sends a positive, the domain controller sends a positive message back to the resource, enriched by the group IDs the user is a member of. And that enables the server to provide authorization for the user, basically look if the user would be authorized to use that share that he's requesting, and if everything is okay, then the access to the resource is granted. So that's how it works. There are problems with that. First off, you see arrows on the right side of the resource, and you see arrows on the left side of the resource. At no point in this data flow was the user obligated to prove their identity directly to the domain controller. Ideally, that would have happened on interactive logon, but it's not necessary in Windows. So there is a divide here, and there is nothing in this authentication flow to ensure that the server or the resource being divided by the red line is actually one and the same entity. So a person in the middle is perfectly possible if you manage to become that person as red teamer. You can talk to the left, to the user, and you can talk to the right, but you can do different things from what the user has intended to. The second problem, NTLM does require a password for every authentication. NTLM does not use any other authenticator than a password. So we are stuck with passwords that have to be typed into a sort of logon form as long as we are stuck with NTLM. Then the cryptographic function, the outer function, the encryption function is solid. It's even solid by today's standards. But the password hash that is serving as key for that encryption is not very up to date anymore, right? MD4, also known as NT one-way function, NTOWF, it's crackable as long as the password has a reasonable size, reasonable length. So relatively weak cryptography. Next thing, again, the resource will be sending all these data packages to the domain controllers. So a replay attack could be theoretically possible, because if you capture a packet containing NTLM authentication, you have all that information at your disposal and could use that for other nefarious things. But Microsoft tried to amend that, and this, of course, happens at the cost of the domain controller knowing about every authentication session that has happened against that domain controller. So it basically has to keep track of every nonce that has been issued for some time, which puts an additional load on a domain controller in Active Directory that is doing NTLM authentication. And of course, as you can see here, at this data packet, it does not require, oh, sorry, here's the cursor. This data packet is completely reproducible using the password hash. So with NTLM, knowing the password hash is equivalent to knowing the password in clear text in terms of providing valid authentication, which leads to the pass the hash attack, which is widely known in the community, both on the red and the blue side. So pass the hash will be possible in your environment as long as resources and domain controllers both support NTLM. So problems with that? The first reaction, of course, would be, okay, let's get rid of that and go full Kerberos. We will look at what's possible in a couple of minutes, but even if you go full Kerberos in your Active Directory-based environment, NTLM is still bad for you. Microsoft had made some design decisions as they introduced Active Directory into the world. And one of those design decisions they made is, if you use passwords, then the ARC4 algorithm in Kerberos is cryptographically equivalent to NT one-way function. Why did they do that? They thought people will take servers with accounts on them and promote them to domain controllers. So local accounts that only have NTLM cryptographic materials will have to be converted to Active Directory accounts, and to provide Kerberos authentication for those, we'll just keep the hash because we do not know the clear text. We can't re-encrypt the password to provide a Kerberos hash using a different algorithm. So we stick to using the same algorithm, right? Which means that if you know the NTLM hash, but the resource or the domain controller will only accept Kerberos authentication, you can't, of course, do pass the hash, but you still can do overpass the hash, which means you request the TGT from the key distribution center from your domain controller, but you use the NTLM hash for that and just tell the domain controller, more or less, I'm simplifying, that it's the ARC4 cryptographic material out of that password. And the domain controller will usually be happy to oblige. Then, hearing that, the knee-jerk reaction would be, okay, let's get rid of NTLM completely in the authentication flow. Let's give every user a smart card, because NTLM cannot use smart cards. So if we give every user a smart card, then they will be stuck with using Kerberos. That is correct. But if you enforce use of smart cards, if you do not enforce use of smart cards, they still have the password. Even if they do not use that password, they still have a password and they still have NTLM hashes of that password flying around. But if you enforce the smart card usage, we're talking about Microsoft here. They are known to put backwards compatibility above both usability and security for decades. So In the Microsoft implementation of Kerberos, there is an NTLM supplemental credential field in the ticket pack, which contains, tada, NTLM hash of what? If the smart card usage is not enforced, then it's the NTLM hash of the actual password. If you enforce the smart card usage, it's an NTLM hash of some very long and random strings, like passwords that computer accounts give themselves. But if your domain has been around for some time, this cryptographic material is static, that it does not change no matter what password policy you have in your environment. So you can't usually crack this thing because it's like 250 characters long and completely random, but you can still use pass the hash with it if resources will accept NTLM authentication. And you can still do overpass the hash with it if your domain controllers will accept ARC4 for TGT issues. So, check this attribute in your domain with a very comprehensive and short name if you're using smart cards and actually enforcing their usage. So there are a couple of problems that we have to take care of. NTLM hash can be harvested. I expect to be at least a dozen people in this room who know more about harvesting hashes than I have ever heard of. But there are many ways to harvest and reuse those NTLM hashes directly as long as the environment supports NTLM authentication. So what can we do to ameliorate that? We should look at restricting harvesting possibilities. We should look, once a hash has been harvested, at restricting usage. And of course, and this is an overarching topic that is not in scope of this session, you should always look at restricting impact if the account has been taken over in this manner, right? So the second one is this condition that ARC4 hash is actually NTLM hash. So the solution approach for that should be getting rid of ARC4 in your Kerberos. That will also help reduce the scope of the Kerberosing attack. The Kerberosing remains possible, but if you only have AES cryptographic material in those Kerberosing tickets, or Kerber-roasted tickets, then the roasting part, the brute force decryption, will take much more time than if you have ARC4, which is basically MD4. NTLM has performance impact. It's not enough to institute a denial of service attack on your domain controllers by providing excessive NTLM authentication, but it's measurable, and it's all the more measurable if you work with virtual machines and your environment is somewhat saturated CPU-wise. Then it could well be possible to even measure the impact of moving away from NTLM and towards Kerberos on your domain controller performance. And last but not least, that is something that people moving to the cloud had encountered. If you start using cloud-only clients, then it's absolutely possible, and has been for some time, to authenticate from a cloud-only laptop that's only joined to Azure ID, or Entra ID as it's called nowadays, to on-premises resources. Using Kerberos, you have to have a line of sight to a domain controller to do that at the moment, but it's possible to use that to do that using Kerberos. So you could have a cloud-joined client that is perfectly capable of accessing on-prem resources, unless those resources are dead set on using NTLM, because NTLM will not be possible from a client that is not domain joined, or at least where the authenticated user is not the domain user, because the cloud does not know the user's clear text password, nor does it know its NTLM hash. It knows a much more complicated hash, like thousand hashing function passes over that hash. But that is no use for basically NTLM. So these is the problems that you will encounter if you try to move away from NTLM in your environment, and there are solutions for more or less all of them. There are scenarios, I mentioned that earlier, where we actually do seem to not be able to avoid NTLM at this time. This is, of course, an interactive offline logon, because Windows is not capable of caching Kerberos cryptographic material at this time, nor would it do you any good, because Kerberos tickets are limited in lifetime. So if you support offline logon to a domain join system, then you are caching NTLM credentials, and so NTLM hash has to be generated when you log on interactively. Where you don't have any Active Directory domain to authenticate against, then you're stuck with NTLM for the time being. No way around it at this time. We will see in a minute what Microsoft plans on doing. Authentication in a workgroup, no matter if your client is domain joined or not, if the resource you authenticate against is a workgroup server, not knowing about the domain, not knowing about Active Directory, or at least not being a member in that Active Directory, then you're stuck with NTLM, because that other system also only can do NTLM for the time being. And there is a use case that is getting quoted rather frequently. If you start accessing resources by their domain IP address rather than by their DNS FQDN, you're stuck with NTLM. That is not entirely true anymore, and has been for some time. But we'll look into that as well in a second. So this stuff has existed for over 30 years. What Microsoft has been doing to help us get rid of NTLM in Windows authentication until very recently was drawing attention to the problems that are there, showing us how we can detect NTLM usage in our environment. You'll have to do that at some point, but Microsoft implied we should start with that. I do not agree with that. That is not what helped people and organizations I consulted for actually move away from NTLM. But there has been zero guidance and zero technical assistance from Microsoft to actually make that move. There are at least 2 blogs in the Microsoft blog space that I know of that start with part 1, getting rid of NTLM part 1. Then they described in great detail how you do the logging and the monitoring and all that data correlation. And then they promised part 2, which never comes. The first one is from NetPile, and it's 15 years old, I think. And the second one popped up fairly recently. So keeping the fingers crossed here that part 2 may actually surface one day, but it's not there yet. But, of course, every time you have Microsoft on premises doing a security assessment, doing a consulting, or even your favorite Microsoft consultant, I was that person until a year ago, they will all tell you, move away from NTLM, that is bad for you. Until very recently. But the team around Steve Seifers, who is the person responsible for Kerberos at Microsoft, actually started doing development to help us to remove NTLM from Windows. There has been a talk by Steve at the Blue Hat conference, which is Microsoft internal conference, one of the videos got published. You will find that when the talk gets on YouTube, you will be able, hopefully, to read that URL. They describe what they are going to do to help us get NTLM free. And what is going to happen in Windows are three things. They are taking up developing the IACurb protocol. It is a sub-protocol of Kerberos that's been in the RFC proposal stage since July 2007. So it's nothing that came from Microsoft. It actually came from MIT, like the rest of Kerberos. But this stuff got proposed in 2007 and didn't move forward much ever since. But now Microsoft putting some weight on that scale to get it to become an official RFC. Keeping fingers crossed here. So what will IACurb be able to do? Every resource that is capable of Kerberos authentication will also be capable of proxying the Kerberos packages that are not designed for that resource. At this moment, the user has to get a ticket granting ticket from the main controller, need line of sight to that. Then, using that ticket granting ticket, it will request a service ticket for a certain service, and then, and only then, it will go out to the resource itself and submit that service ticket to get access to the resource. So this all communication flow will be proxied through the resource. So especially in a cloud scenario, in a VPN scenario, clients will not need line of sight to a domain controller to do Kerberos authentication, but only the line of sight to the resource that they plan on accessing anyway. Happy days. The second part, removing dependency on NTLM for offline and workgroup scenarios. Right. Every Windows system at some point in the future will get a local KDC, a local key distribution center implemented on that system, which will allow us to actually do a Kerberos authentication in a local scenario. And the great thing about that is that Kerberos does not, contrary to NTLM, rely on passwords only. So you will be able to do like smart card certificate or FIDO2 authentication on a workgroup, on a standalone Windows system. Keeping fingers crossed here. And this is in the works already. Per service NTLM enablement. You might have that one application that you need for the next 2 years. You know it goes away in 2 years, but you need it for the next 24 months, and it only can do NTLM. And the programmer who developed that is dead and took the source code with them into the grave, right? I mean, it's a normal scenario, right? Even at Microsoft, there have been tools at Microsoft where a certificate has expired and nobody knew where the source code is. If you have one such service, you will be able, at some point in time, to only enable NTLM authentication for that particular service, but disable it globally on the system providing the service. Great stuff. The first step has been taken already. In my opinion, it's at the wrong end of the scale, but it's probably what was easiest to implement. You will be able very soon to turn off NTLM authentication in SMB, Windows File and Print Sharing Protocol, if that is not needed for accessing that protocol. So, this is what Microsoft will be doing to help us get rid of NTLM. They are doing that, but it has not surfaced outside of their development environment yet. The second takeaway from this video is they did some telemetry analysis on NTLM authentication of large enterprise customers and slightly smaller enterprise customers that agreed to give them that information. And they broke down the NTLM usage by the condition causing that usage. And I mean, it's to be taken with a grain of salt, of course, but in their reckoning, 52% of NTLM authentications today come from applications where someone at some point in time hard-coded using NTLM into that application. Espinego was part of the Microsoft development offerings for the last 20 years. The urgent recommendation to use negotiate as the authentication interface in your applications, if you're a developer, dates back to 2010. And you still find application manifests, even source code, where NTLM is hard-coded as the authentication package to use. Espinego will fall back to NTLM if it can't negotiate Kerberos. So nothing should theoretically break if you change NTLM to Espinego in your applications. And of course, that thing with IP addresses rather than FQDNs, service addressing, that is more on the implementational side of things. It's more the admins who make their lives easier, but not relying on DNS, because they don't like the person managing DNS, and because everybody, me included, keeps tweeting about DNS being the source of all problems out there, right? So like 0 days since it was DNS, tear off calendar. But since Windows Server 2016, I think is one of the CUs that came out shortly afterwards, it's possible to use IP addresses in SPNs. And you're not enabling it globally. You must set a registry key on a client. The client must be a Windows system, because other Kerberos implementations still do not allow that. If you set that registry key on a client, and if you set a IP address-based SPN on the service account or computer account running the service, then you should be able to obtain a service ticket for that service using IP address of the system providing the service. So that's what the rest of the world is doing. Basically, depending on who is your software provider of choice, nothing at all, or maybe reluctantly replacing that NTLM by Espinego, making a smoke test failing, and then replacing it back because they have to meet shipping deadlines. So it's on you to pester your application providers if you detect NTLM being hard-coded in that application. Now, what can you do as admins, defenders of the systems, until both Microsoft and your application vendors fixed this stuff? Several things. First and foremost, go ahead and disable the previous versions of the protocol if that is not in place already. NTLM v1 enables the attacker to do a simple package replay. LAN Manager restricts password length to 7 characters. So if you have a 21-character long password, only the first 7 characters will be used, and to make matters even worse, they will all be converted to uppercase. Yeah, so any environment that is semi-modern in terms of operating systems and development frameworks being used should not be affected by disabling LAN Manager and NTLM version 1. Your mileage will, of course, vary as is always the case in IT. But this is like 40% of the attack surface reduction of NTLM. Just kill the older versions. NTLM v2 sucks as well, but it does not suck nearly as badly as the other two. Try to disable ARC4 in Kerberos. Microsoft tried to force that on us in, I think, October or September CU. That didn't go very well. October or September last year. That didn't go very well. Many environments that actually hardened Kerberos in terms of encryption protocol had to re-enable ARC4 for some time at least, until the CU got rolled out to all domain controllers and all affected systems. Then they were perfectly able to re-disable ARC4 in Kerberos. But absolutely look into this, because as long as you have local password-based authentication and Kerberos accepting ARC4, then hashes can be harvested on your endpoints and maybe even servers, and hashes, NTLM hashes can be used for overpass the hash attacks. Put interactive admin accounts in the protected user group. That restricts their ticket lifetime to 4 hours, but for interactive administration, that should be enough. And this is the only method available to you today to basically effectively disable NTLM for one particular account. Authentication policies. I could talk about authentication policies for a week. I have actually done so in workshops with customers. It's the best feature in terms of Windows security that's been published since sliced bread, and it's as old as protected users. It came out with 2012 R2. Nobody using that. And this is a vicious circle, because nobody using that, nobody wrote about that, and because nobody wrote about that, nobody's using that, and so it goes on. Then there is something you can absolutely do: restrict pass-through NTLM authentication in your environment. That is the next topic, and I can't repeat it often enough. Least privilege in all systems. So reduce the impact, reduce the outcome if you can't get rid of the cause. If you're already hybrid with Entra ID, absolutely take a look at moving clients into the cloud, because they will able to do Kerberos to your on-prem resources if you set it up that way. But they will not be using NTLM anymore. So, getting rid, you're getting the drift, right? Getting rid of NTLM is nothing that you can do by pulling a lever. It's a journey. What Microsoft said about the journey, I quoted that already: start monitoring for now, and we'll get back to you when we've figured it out. You'll drown in logs underway. We will see in a second how many logs that will be. What really worked in my experience is start by taking tier 0 and admins in general out of the equation. Get rid of NTLM for your highly privileged account, harden services and service account, both in terms of NTLM and Kerberos, ARC4. Enable Kerberos in your applications whenever possible. There are those applications that could use Kerberos, but you have to tell them to do that. Least privilege everywhere. And then you are at the point where Microsoft suggests that you start your journey. Then, when you have done all that homework, you start monitoring for identities at first to determine what users are actually using NTLM in your environment, because that is the lowest hanging fruit. We'll see that in a second. And then, when you're at the end of that investigation, then start monitoring the whole signal chain. And if you're done with that and know what's going on in your environment, then you restrict the network authentication. And for the moment, you would be done with what is possible. So, disable NTLM V1 and LM. If it still breaks your stuff in 2023, then you have other problems than sitting here at a conference. You should be looking for a new employer. Isolate admins from NTLM, protected users, Kerberos authentication policies, Red Forest. Microsoft confused people by declaring the ESA management infrastructure for deprecated. If you're on premises, it's still valid. Take care of services and service accounts. Use FQDN everywhere. Yes, you can use IP addresses or host names in SPN, but you actually really shouldn't. You can put FQDNs everywhere where a computer has to be addressed, and then chances are your applications start using Kerberos all by themselves. Use UPNs. This is actually not necessary in most cases, but it helps. Verify that SPNs that you would be using to request service tickets are actually in place. SQL service accounts not granted rights to set their own SPN. And Kerberos authentication policies. Go ahead, look into it. If you have questions, and you will, hit me up on Twitter. We can talk about that. You'll have to get to know your environment to achieve this. Document those systems that you find not being Kerberos capable at the time, and start pestering the vendors or your purchasing department about upgrading those. But there are plenty of systems in a typical environment that could absolutely use Kerberos, but are not configured to use it. Exchange, if you have a load-balanced Exchange organization, chances are that the Kerberos infrastructure is either not in place or outdated, and they fall back to NTLM. SQL, clusters are potential candidates for NTLM. DFS, if you use a standard wizard for creating a DFSN namespace, chances are you end up using NTLM at some point. Network printing. Network printing is a real problem where NTLM is concerned. RDS connection brokers. The first Microsoft idea of having an RDS farm could support Kerberos. The current infrastructure cannot if you have a load-balanced RDS farm. And least privilege for all systems. So, now, the last minute. Here are the logs you will be drowning in. To monitor NTLM usage in your systems, you would want to know what user authenticates via NTLM to what resources on what servers, and what client application has caused this authentication flow, right? To get to this information, you actually need 3 sources. They have been part of Windows since 2008. You could get client, user, and server, not knowing which application accesses which resource, by only monitoring the DCs. These are the data fields that you will get from your DC. You could get a client, an accessing user, and the actual resource being accessed by monitoring the server. And if you want to have the client application, you have to monitor the clients. That's why I say you do not start monitoring the whole signal chain from the get-go, but you start by monitoring the DC. Make sure that no highly privileged users come up in those logs after you're done remediating. And then you could start collecting server logs, and in the end, you could start collecting client logs that may provide you with further information. And as the last step of that journey, at least as far as it's possible today, you put all the servers that you cannot remediate today on the exclusion list, restrict the NTLM authentication in your domain, and work through the exclusion list together with your purchasing department. Arc4, get rid of Arc4 and Kerberos. That's the best thing I could do for you. Also helps with Kerberosing. And when your exclusion list is empty, you're almost done, and all that you have to do is wait for Microsoft to provide IACURB and local KDC, and then you can have NTLM-free Windows. Thank you very much.
Thank you very much, Evgenij. You are perfectly on time. Don't worry at all. That was great. We will have a break now of half an hour. Our next